Hey guys, it's me. Sorry it has taken me a while to get this video to you. I know I said I was going to do it before noon today, but I had some technical difficulties, and then obviously watching football, as you can hear in the background. Anyway, I normally like to make my videos in a classroom so that I have the backboard and some other things, but I am at home, so you're just going to have to hear me for the next like 10 minutes. Anyway, I attached a periodic table for you to use during this, as well as a worksheet that I need you to fill out. They're both on ELC as well. So what we're going to talk about today is the structure of the atom, and we're going to keep it really simple and just kind of go over the basics that you need to know for our lesson on Monday. So we'll get started with the three subatomic particles in the atom, and we'll talk about each one of those in a little more detail. So the first one that we're going to talk about are going to be our protons. And these are the kind of things that really need to be stuck in your head so that when someone says something about a proton, you can say, oh, it's in the nucleus. It has a positive charge, and it contributes 1 atomic mass unit to the atomic mass of an atom. So each proton has an atomic mass of 1 atomic mass unit. Sometimes you'll see that as an AMU for the abbreviation. So again, that's protons in the nucleus, positive charge, and 1 atomic mass unit is what it contributes for each proton that you have in that atom. A lot of times people will argue that protons are the most important subatomic particle that you have in an atom. And the reason for that, if you look at the periodic table, you'll see your block of your elements, and at the top it have an atomic number. So let's take, for example, gold. So if you find gold on the periodic table, the chemical symbol is capital A, lowercase u. You'll see that it has an atomic number of 79. Well, the atomic number represents the number of protons that are present in an atom's nucleus. Okay? So this is really, really important. Every element or every atom of gold is going to have 79 protons in it. If it doesn't have 79 protons, then it's not going to be gold. Okay? If it has 50, not gold. If it has 80, not gold. It's a completely different element. So when we're talking about protons, we can say, yeah, you know what? They are pretty important. Are they the most important? I mean, we'll see. You know, that's something that we're going to work on deciding, and you guys can figure that out for yourself. Everything is going to play a specific part in what an element does and how it behaves. But what we need to know is that the atomic number is equal to the number of protons. So we looked at gold. We see that gold has an atomic number of 79. Means it has 79 protons. Okay? If you change the number of protons, you change the element. So what I want you to do with your periodic table is I want you to look and find the elements that have the following atomic numbers: 78, 80, 19, and 20. So there's two things that I want you to look at. One, I want you to be able to find the atomic number, know that it's associated to the number of protons, and then also know which element is represented by those. So make sure you write those down. Which element has 19 protons, which element has 20 protons, which element has 78, and which element has 80. Okay? The next thing that I want you to do is also to look and see if you notice a trend by doing that activity. It was a quick 30-second thing that you did. Did you see a trend based on the atomic number or the number of protons, and how the periodic table is set up. Okay? We'll talk about that more on Monday as well. All right, the next thing that we'll talk about are the neutrons. They're also going to be found inside the nucleus, and there's a reason for that, right? Protons, we said, have a positive charge, and if you know anything about magnets, or even if you just heard this saying that opposites attract and like repels. So if you have just a nucleus full of protons and all of those positive charges, then what's going to happen? The nucleus is not going to be stable. Those positive charges are going to repel and push each other apart, break apart the nucleus. Therefore, we have these neutrons in there that kind of balance it out, give the protons some space so they're not that close to each other, so that they can't be so disruptive. So our neutrons are going to be inside the nucleus as well. They're all going to have no charge. So what I always like to tell my students is that you can kind of put some things together so that it's easy to remember. I say that protons start with a P, positive starts with a P. Now, it doesn't work for neutrons, right? Because then you would say neutrons start with an N, maybe they should have a negative charge. But for neutrons, think about the word neutral, right? They both start with the same prefix, and neutrons will be neutral, have no charge. That's important. The neutrons also contribute 1 AMU for each neutron that's present to the element's overall atomic mass. All right? So that's kind of as far as we're going to go as far as what role the neutrons play. The next thing that we'll talk about is how do you determine the number of neutrons in an element. If you look at the periodic table and you're seeing your box and it has these numbers, it has an atomic number and it has an atomic mass, but it doesn't say anything about the number of neutrons. So question, is it the atomic number? No, that's the number of protons. That's what we talked about 2 minutes ago. Is it the atomic mass? Not completely, but it's going to make up part of it. So this is one of the things that always kind of confuses students, and because there are a number of variables inside of this formula, you may have trouble with 8th and 9th grade students, especially maybe low-level students. So what you need to know is that your atomic mass is equal to the number of protons plus the number of neutrons. Atomic mass is equal to the number of protons plus the number of neutrons. Okay, pretty simple, right? You can write out the equation, X equals A plus B. If you look at the periodic table, they give you the atomic mass. They give you the atomic number, which is equal to the number of protons. So all you need to do is figure out the number of neutrons that are in there. Simple subtraction, right? And we're going to look at one right now. And what did I wrote down that I want you to find beryllium on your periodic table. Okay? You found beryllium? So if you look at it, beryllium has an atomic number of 4. So that means that it has what? Right. It has 4 protons. So then what you also see is that it has an atomic mass of 9.012. So we're always going to round to the nearest number. So for this example, it's going to be 9. So you've got 9 equals 4 plus the number of neutrons. If you subtract 4 on both sides, you find out that the number of neutrons is equal to 5. 4 protons plus 5 neutrons equals 9 for the atomic mass. It's pretty simple, right? But that leaves a question. Why are electrons not included in the atomic mass? They're part of an element. So what I want you to do is think about this yourself, what you know already, the knowledge that you have in your brain, not your phone, not your computer. Write out a statement as to why electrons would not be included in the atomic mass of an element. And we'll talk about that later. But I definitely just want to see what your pre-thoughts are on that. All right. So we have one more example I want to do with you for atomic mass and atomic number and number of neutrons. So if you find cobalt on the periodic table, and cobalt is abbreviated capital C, lowercase o, what's the atomic number? All right, the atomic number is 27. You should have all gotten that. You have your periodic table in front of you. What does it mean for an element to have an atomic number of 27? You should also get that it means that you have 27 protons. So that's part number one. Now, again, looking at the box on the periodic table, what's the atomic mass? Okay? Yep, atomic mass is going to be 59. So if you set up your equation, you would have, and I'm going to write it out, 59, which is the atomic mass, is equal to the number of protons plus the number of neutrons. Well, I know the number of protons is 27, so I'm going to plug that in. 59 is equal to 27 plus the number of neutrons. If I subtract 27 on both sides, I get that the number of neutrons is 32. Right? Simple math again. We'll do some more that you can practice. If you have any questions, we'll clear all that up on Monday. But it's pretty straightforward, again, to figure that out. Just have to work at it, and you do it enough times, it'll just roll off your tongue like that. So the last thing we're going to talk about as far as the subatomic particles, there's going to be our electrons. Electrons are going to have a negative charge. So each electron has a negative charge. Each proton has a positive charge. Each neutron has no charge. Got it? Got it. They're found on the outside of the nucleus. So they're not going to be inside the nucleus with the protons and the neutrons. The electrons are going to be outside. And what we call that is they're found in electron clouds outside of the nucleus. Now, we will only deal with 3 electron clouds for this class. Okay? So we're going to have the first electron, second electron, third electron cloud. That's it. Now, it gets a lot more complicated. You'll get that in chemistry. But for this physical science class, we're just going to deal with the first 3 electron clouds. Alright? Now think back when I asked you a question and I said, why are electrons not included in the atomic mass of an element? And the reason is pretty simple. Some of you may have gotten it. We'll talk about it if you need to. But electrons are super, super, super small. Now, obviously, we're talking about things that we can't see. They're all small. But an electron is 1,850 times smaller than a proton or a neutron. So the mass is really insignificant in the overall scheme of it, so it's not included. So now the next question that you may be thinking about is, okay, well, if they're not in the nucleus and their mass is insignificant, why are they important? And that's something that we're going to do in class together as to why they're important, so you can kind of figure out, okay, what's the most important, protons, neutrons, or electrons? And I always like to have my kids kind of debate, and I want to see what your thoughts are going to be about this while we're in class also. Alright? The next thing is, if we have an atomic number that tells us the number of protons, and we have an atomic mass that we can use a formula to figure out the number of neutrons, how do we figure out the number of electrons present? Pretty simple, actually. In a neutral atom, this one that has no charge, the protons and the electrons are going to be equal to each other. And that would make sense, because if you have 18 protons, that gives you plus 18, because each one of them have a positive charge. you'd also have to have 18 electrons, each of them having a negative charge, to balance it out and give you a neutral element. So the number of protons will equal the number of electrons. Here's some examples. So find potassium on the periodic table. It has a chemical symbol of K. Should be pretty simple for you to find, pretty easy. Potassium. Everybody loves potassium, right? It's found in bananas mostly. That's what we always talk about, having potassium in our bananas. What's the atomic number? Okay, atomic number is going to be 19. The atomic number is equal to the number of protons. So the number of protons present in potassium is going to be 19. Well, if I told you that this element doesn't have an overall charge, that means that the number of protons is equal to the number of electrons. So we have 19 electrons also. Okay? If you want to figure out the number of neutrons, look at your atomic mass, subtract the atomic number, and that will give you the number of neutrons for that. Okay? Now, we've kind of gone over them. We've said kind of where they are, the electrons in the clouds outside the nucleus, but they have a special, specific arrangement that we're going to be working at, and it really determines why electrons are important to an element. Okay? So I said earlier that we were going to talk about 3 electron clouds. The electron clouds are going to hold a specific number of electrons. Your first electron cloud is going to be the one that's closest to the nucleus, and it's going to hold 2 electrons. Once that electron cloud is full, then electrons start filling the second cloud. It's a little further away from the nucleus, and the second cloud is going to hold 8 electrons. Once all of those are filled, then the electrons start moving out to the third electron cloud, and it, for our class, is going to also hold 8 electrons. Okay? So the first cloud holds 2 electrons, the second cloud holds 8 electrons, and the third cloud is also going to hold 8 electrons. So let's look at this and see how it works. I want you to find lithium on your periodic table. Lithium has a chemical symbol of capital L, lowercase I. Everybody should have found it. The atomic number is what? 3. So that means it has 3 what? It has 3 protons. It's a neutral atom, so the number of protons is going to equal the number of electrons. So it's also going to have 3 electrons. Alright? So now what you want to do is you're going to draw your nucleus as a circle. Pretty simple. Fill it in with your protons and your neutrons. Draw your electron clouds. And you want to fill in the first electron cloud with how many electrons? 2. Right? Lithium has 3. So after we fill the first electron cloud with 2, the next electron cloud is only going to have 1 because you have 3 total. So you can fill that in also. Okay? Now, that's the rule that you need to remember. You have to fill each electron cloud completely before you move to the next one. So if you look at how I drew it, right here, I don't know if you can see that very well. Let's see. Okay? If you see there, there's my nucleus. It has 3 protons and 4 neutrons. I've drawn an electron cloud, and there are 2 electrons. I have 1 more electron left over, so it goes out into the second electron cloud. I finished that. Now, I know this has been a lot of information. Hopefully it's all made sense, but I have one more piece to go over you. If you notice how many electrons are in that outermost cloud for lithium. Pretty simple, right? We just looked at it. We did it. There's 1 electron in the outermost cloud. Electrons that are found in the outermost electron cloud are called valence electrons. So if I asked you how many valence electrons lithium has, it would only be 1. If I asked you how many total electrons it has, it'll be 3. Got it? Got it. See you guys on Monday. Make sure you have your worksheet filled out. And we have a couple of activities that are going to help you understand this and put it into practice. I look forward to seeing you guys. Have a great weekend.